Hello everybody. This is lesson 8 of the lecture International Financial Markets. In this lesson I will discuss the slides 67 to 87 of chapter 2 Major Market Segments and their Assets. In this lesson I will talk about foreign exchange markets and the major factors that influence the exchange rates between different currency areas. Why do people demand foreign currencies at all? Well, one motive are lower prices for goods sold for foreign currencies, typically in other currency areas. In such a case, domestic consumers or their retailers and intermediaries want to buy foreign goods and need foreign currencies to do so. Another motive might be higher interest rates and expected returns of securities denominated in foreign currencies, for example, American stock or American government bonds. In such a case, domestic savers or their banks and investment funds want to buy foreign currencies and need foreign currency to do so. These considerations show demand and supply on foreign exchange markets are influenced by two important factors: the relation between domestic and foreign prices for goods, for example, the euro price for goods or a bundle of goods, versus the dollar price for the same good or the same bundle of goods, and on the other side the relation between domestic and foreign interest rates, for example the interest rate for a European government bond and an American government bond with the same maturity and within the same risk class. In the following, we will study these relationships in some more detail. Let's start with the relation between the exchange rate and the prices for domestic and foreign goods. We can find the accurate relation between the exchange rate and prices for domestic and foreign goods with the help of a simple numerical example. Where would you buy, let's say, cookies at the following exchange rate and the following prices? Let's assume that the price for a kilogram domestic cookies equals €1 and the price for a kilogram cookies in the United States equals $2. So this is the euro price and this is the dollar price of a kilogram cookies. If the exchange rate would equal $4 for €1, what cookies would be cheaper, American cookies or European cookies? Let's calculate the price of American and European cookies denominated in euro. So the price of cookies in euro is already well known. It's €1 for 1 kilogram cookies. That's quite simple. To find the price, the euro price of a kilogram cookies in the United States, we have to use the exchange rate. We have to divide the dollar price over the exchange rate. In this case, the dollar dimension cancels and the euro dimension stays. If we fill in the numbers, we have $2 per kilogram cookies over $4 for €1, and this yields a euro price of American cookies of €0.5 for 1 kilogram American cookies. So obviously cookies are cheaper in the United States given this exchange rate and these prices. So what would happen then? Well, nobody would like to buy cookies in the euro area since they are much more expensive. Instead, all people would try to buy cookies in the United States. So Europeans would demand dollar and at the same time, that's basically the same kind of transaction, supply euro. Would demand dollar and supply euro. It's basically the same because if you demand dollar, you have to give away euro. So supply of euro implies demand for dollar and vice versa. As a result, the currency that is supplied depreciates against the currency that is demanded, the dollar. So the exchange rate of dollar per euro would decrease. This means, however, that an exchange rate of $4 for 1 euro cannot be an equilibrium exchange rate. So this is a numerical example for a situation where the foreign exchange market cannot be in equilibrium given these prices and this exchange rate. Now let's try another exchange rate. Let's assume that the exchange rate is not $4 per euro but only $1 per euro. So compared to the initial situation, the dollar has now appreciated a lot. What currency area offers now the cheapest cookies given this new exchange rate? Well, let's start again with a comparison of prices. The euro price of cookies is still unchanged, it's €1 per kilogram. But if Europeans want to buy now American cookies, they have to exchange their euros into dollars first before they buy the American cookies at their dollar prices. So we have again to divide the American price over the exchange rate. Given the new exchange rate, this results in a euro price for American cookies equal to €2 for 1 kilogram American cookies. So now clearly the European cookies are cheaper. Euroland offers the cheapest cookies. What would happen now? Well, now of course the opposite happens. Nobody wants to buy cookies in the United States, so American would try to buy cookies in Euroland. As a result, they would now demand euros, so the demand for euro grows, and at the same time they would supply dollars, so the supply of dollar grows. As a result, the currency which is demanded appreciates. So now the euro would appreciate against the dollar. And this means, of course, that an exchange rate of $1 per euro can also not be the equilibrium exchange rate. So we have now found an exchange rate which is too low, and in the first example the exchange rate was too high. And this means, of course, that the equilibrium exchange rate should lie somewhere in between $1 per euro and $4 per euro. How do we find this still unknown equilibrium exchange rate? Well, it's of course quite simple. We can set up an equation where we leave the exchange rate as an unknown variable, and then we can solve for this unknown variable. So what we have to do is equate the price of cookies in dollar over the exchange rate dollar per euro with the price of cookies in euro. This is our equation which we have to set up. Now we can fill in the numbers for the price of cookies in dollar and the price of cookies in euro. And then we have to solve for the unknown variable. This is one equation with one unknown variable, and in this case we can solve for the exchange rate. So we multiply both sides of the equation with the unknown variable, then it disappears on the left side and reappears on the right side. And next we divide both sides of the equation over 1 euro, the price of cookies in euro. Then the price of cookies in euro disappears on the right side, reappears here as the denominator of a fraction on the left side, and then we can simply calculate the resulting number, which is $2 for 1 euro. So $2 for 1 euro is the equilibrium exchange rate. At this exchange rate, cookies have the same price in the USA and in Euroland. We have calculated the cookie price here in terms of euro. You can also calculate the cookie price in terms of dollar, and you will see at this exchange rate the price is always the same, whether you calculate the price of cookies in dollar or in euro. That makes no difference. So this is our equilibrium exchange rate now, $2 per cookie. Consequently, a necessary condition for an equilibrium on the exchange market is that all goods which can be traded between two currency areas have the same price, whether measured in euro or in dollar. At an exchange rate of $2 per euro, no additional demand or supply for dollar or euro is caused. In this sense, the exchange rate has reached an equilibrium level. This relation is called purchasing power parity because both currencies have the same real purchasing power given this equilibrium exchange rate. At this exchange rate, you receive the same amount of cookies for 1 euro, whether you buy your cookies in the euro area or in the dollar area. We can derive from this relationship the so-called purchasing power parity formula. Here we measure the purchasing power parity formula in euro as we have done so far. In this case we have to divide the dollar price over the exchange rate. If you multiply this equation with the exchange rate, it disappears on the right side and reappears here on the left side. And now we have expressed the prices of cookies in the euro area and the dollar area measured in dollar. So this shows that prices of cookies is always the same, whether measured in euro or measured in dollar, if this relation is given. We can also solve the equation for the exchange rate. For example, if we divide this equation over the euro price of cookies, and then we see that the purchasing power parity exchange rate is given by the price of cookies measured in dollar over the price of cookies measured in euro. However, there's one big however here. The simple purchasing power parity formula does only hold for goods whose transportation costs or other kind of transaction costs like insurance costs or let's say import tariffs are close to zero. Of course, for most goods this assumption is not justified. In this case, the formula must take care of these transportation costs and other transaction costs. As a result, there is a band around the purchasing power parity exchange rate in which the exchange rate is not affected by goods prices. In reality, transport costs for most goods are between 0 and infinite. Besides transport costs, there are also other factors preventing a strict empirical validity of the purchasing power parity relationship. For example, as already mentioned, tariffs, import tariffs, and quantitative restrictions in international trade can act like transport costs. And then we can also have monopolies or oligopolies which allow companies to apply profit maximizing price differentiation strategies between different currency areas. So consequently, there exists a kind of bandwidth around the purchasing power parity exchange rate within which the actual exchange rate cannot be affected by international trade. If there are these type of transaction costs, and if we express these type of transaction costs with capital letter C here in terms of dollar for one good, so these are the transaction costs expressed in dollar for one unit of the good which is traded, the formula for the purchasing power parity exchange rate must be modified according to the following one. You find mathematical derivation of this inequality formula in the following digression, which I will not discuss. But it's quite simple to derive this formula if you take a look in the following digression. In this case, the actual exchange rate is free to move, unaffected by international trade between a lower and an upper border around the purchasing power parity exchange rate, which is given by these ratios. This means the higher the transaction costs, measured here by capital letter C in dollar, the lower the effect of international trade on the exchange rate. For example, if you have two currency areas which prohibit international trade, which live under autarky, the transaction costs would be infinitely large, and therefore the exchange rate can of course not be affected by international trade. If transaction costs are actually infinitely high, there will be no trade and the exchange rate can not be affected by trade. If the transaction costs are zero or close to zero, the exchange rate will be completely determined by the prices for tradable goods. In this case, we can modify the equation, so we have to fill in a zero for the transaction cost measured in dollar. Then this fraction disappears on both sides of the equation, and we observe that the actual exchange rate must be larger or equal to the purchasing power parity relationship and smaller or equal to the purchasing power parity relationship. And this is of course only possible if the exchange rate is exactly equal to the purchasing power parity exchange rate. So for goods where transaction costs are zero, the purchasing power parity exchange rate should hold 100%. typically digital goods that can be traded and transported over the internet, have very low transaction costs, of course. Let's have a look on the purchasing power parity relationship from an empirical perspective. The green line represents the actual exchange rate of the euro against the dollar in terms of dollar per euro. The dashed red line represents the purchasing power parity exchange rate of the euro against the US dollar, calculated on the basis of the prices of a standardized basket of consumer goods. The transaction costs band lies, according to our formula, around the purchasing power parity exchange rate. Within this band now, the actual exchange rate cannot be influenced by international trade. So it's undetermined within this band. Given these transaction costs, the actual exchange rate is either not high enough to cause imports or not low enough to cause exports. In a world without transaction costs, the transaction cost band would be zero, so these dashed red lines here and here would be identical with the purchasing power parity dashed red line here in the middle, and as a result the actual exchange rate would always follow the purchasing power parity exchange rate, such that the green and the dashed red line would also be identical in this extreme theoretical case. This diagram shows the development of the actual exchange rate and the purchasing power parity exchange rate between the franc français and the Deutsche Mark from the year 1960 to the year 2018. Here the dashed red line equals the logarithm of the actual nominal exchange rate. That's what we've got so far, the exchange rate. The continuous blue line, this line here, equals the purchasing power parity exchange rate. Both rates, the nominal exchange rate and the purchasing power parity exchange rate, have the dimension Deutsche Mark over franc français. So this diagram uses the inverse dimension we have used so far. To calculate the purchasing power parity exchange rate, the bundle of goods used to measure the consumer price index of both currencies is used. The values are all expressed in logarithms. The diagram reveals that until the beginning of the 90s, the French consumer price index, which is in the denominator of this fraction here, was growing faster than the German, such that the purchasing power parity rate between both currencies displays a strong downward trend, the blue line here. Roughly 10 years before the foundation of the European Currency Union, the relationship, however, stabilized and the purchasing power parity exchange rate displays a sideward trend along a level of 0, which corresponds to a level of 1 in de-logarithmized terms. Since the beginning of the European Monetary Union in the year 1999, the nominal exchange rate between France and Germany has been fixed at a level of 1, such that the logarithm equals always 0. French euros and German euros exchange at an exchange rate of 1. That is the point here. As the purchasing power parity exchange rate indicates, the blue line, the diversion of price levels has become smaller. There are still small deviations which indicate that transaction costs probably still play a significant role. All in all, however, the diagram shows that the actual exchange rate, the red dashed line, followed the purchasing power parity exchange rate, the continuous blue line, in the long run, especially during the period before the 90s. The franc français displaced a steady depreciation against the Deutsche Mark in order to compensate for the higher French inflation rate. And this is exactly what the purchasing power parity theory predicts for such a case. But we also observe significant deviations, for example here, of both exchange rates, which indicate that transaction costs prevented a closer convergence of the nominal exchange rate and the purchasing power parity exchange rate. For other country pairs, a similar development of actual and purchasing power parity exchange rate is obvious. For example here, between Germany and Spain, or Germany and Italy, Germany and Ireland, or Germany and Portugal. The story is basically the same in these cases. Let's finally transfer our results about the impact of goods prices on the exchange rate on a diagram of the foreign exchange market. From the perspective of trade in goods, supply and demand curves on the foreign exchange markets should have the normal slopes. The demand curve for euro should have a negative slope because the cheaper euro, the cheaper are goods from the euro area for foreigners. So if foreigners want to buy more goods from the euro area, they will have to exchange more dollars and euros. So the euro demand increases as the euro gets cheaper or depreciates. On the other side, the supply curve for euro should have a positive slope because the more expensive euro, the cheaper are goods from the USA for domestic Euroland consumers. If domestic consumers want to buy more goods from the USA, they will have to exchange more euros into dollars. So the euro supply increases as the euro gets more expensive or appreciates. On the market where euro is traded for dollar, we measure the exchange rate on the y-axis in terms of dollar per euro, and the volume of traded euros on the x-axis. The demand curve for euro has, as just mentioned, the usual negative slope, since the less dollar has to be paid for 1 euro, the more euro goods are cheaper than dollar goods, and therefore the more euro is demanded in exchange for dollar. The euro supply curve has the usual positive slope of supply curves, since the more dollar is paid for 1 euro, the more US goods are cheaper than euro goods, and hence the more euro is supplied in exchange for dollar. The intersection point of both curves provides the equilibrium exchange rate between dollar and euro, and this would be the equilibrium transaction volume. What happens now to the equilibrium exchange rate if inflation in the United States is higher than inflation in the euro area? Prices for goods do not appear on the y-axis, hence they are shift parameters. If goods in the United States become more expensive, Americans will try to buy more goods in the euro area, where prices are now cheaper. Consequently, the demand curve for euro shifts upward or to the right. Here symbolized by this new price level for dollar goods compared to the initial price level, which is higher than the initial price level. Since less Europeans want to buy goods in the United States now because US prices are more expensive as before, Europeans demand less dollar and hence supply less euro to the foreign exchange market. Consequently, the euro supply curve shifts to the left. As a result, the euro appreciates against the dollar, since the new intersection point lies now on a higher level. The new equilibrium exchange rate will be this one. So the graphical analysis comes to the same result as the purchasing power parity equation, which indicates that if the price level in the United States goes up, the euro will appreciate against the dollar. To sum up our results, international trade causes the exchange rate to adjust for inflation differentials between two currency areas. If the inflation rate in the United States is higher than the inflation rate in the euro area, the exchange rate of the euro against the dollar will appreciate. If inflation in the United States is lower than inflation in the dollar area, the exchange rate of the euro against the dollar will depreciate. So much for this lecture. In the next lecture, we will analyze the influence of differences in interest rates on the exchange rate.